So welcome everybody to this latest GCSE revision video on 162 Maths, and in this video we'll be going over the AQA topic test higher on equations of a circle. Now there will be, as always, a copy of the worksheet in the description below for you to have a attempt at before going through watching this video and going through the answers. So before we get started, let's have a look at the key principles and concepts that you need to revise and remember. So the first thing is that the equation of a circle with centre 0, 0, or the origin, and a radius of r will have this as its formula. Now this is probably the most common for higher GCSE. However, depending on what level you're looking at in terms of the higher, whether it's grade 7, 8 or 9, or even at level 2 further maths, then you may encounter this formula, which is when you've got any centre, so when the centre is not the origin with radius r, it follows this formula here. Now where a and b is the centre coordinate, and obviously if it's 0, if a is 0, b is 0, then it would give us this formula here. So these are the two general formulas for areas of a circle, with the latter one being more that's used at a higher level. Now, as well as the formula, there are simple concepts of coordinate geometry that you also need to be aware of. Now, whenever you see the word intersection or the words that meet, basically what that means is that you're going to be using simultaneous equations. So try and substitute one equation into another. And again, there's a video that covers one nonlinear equation and one linear equation and substituting to solve them simultaneously. The next concept is looking at circle theorems, in which that a tangent meets the radius at 90 degrees, which therefore means that the gradient between the two lines, so let me just write this down, so the gradient between the tangent and the radius will equal 90 degrees. So in other words, what you've got is minus 1, let me write it properly. So we've got the gradient of the line times, or the tangent I should say, not the line, multiplied by the gradient of the radius equals minus 1. And also another concept that you may need to find is the equation of a line. So sometimes you might be asked to find the equation of a tangent, and again the formula I would use is y minus y1 equals x minus x1, where m is the gradient and x1, y1 is the coordinate that the line passes through, often a point on the circle if it's a tangent point. You can use y equals mx plus c by all means, there's nothing wrong with that, but I always say that this formula is probably the most efficient and also one that's probably going to last you a little bit longer going forward into A level. So let's have a look at some of these questions. So let me just zoom in a little bit too much in terms of the notes. So in terms of here, let's have a look at question 1. So question 1 says the equation of a circle is x squared plus y squared equals 2. Circle the value of the radius. Now the key thing to remember is that this value here is the radius. Well, actually it's not the radius, that represents r squared. So if r squared equals 2, r is going to equal the square root of 2, which is this value here. Now you don't need to worry about plus and minuses, because obviously radius represents length and you can't have negative length. So looking at question 2, it says that the circle has a centre of 0, 0 and a radius of 3. Circle the equation. So again, what we've got is x squared plus y squared equals r squared. So if r equals 3, that's going to equal 9. So what we've got then is our first option. Question 3 then says that the area of a circle centred at the origin is 25 pi. Work out the equation of the circle. Now what we need to do here is that if the area equals 25, oh no, what I was doing there, let me just correct that. We've got 25 pi. And what we need to do is work out the radius. So the area is pi r squared. And if that's equal to 25 pi, then obviously the pi's cancel out. And so r squared equals 25, and as I mentioned, therefore r must equal 5. So then if the radius is 5, then the equation of the circle at the origin is going to be x squared plus y squared equals 5 squared, or what you could write is x squared plus y squared equals 25, and that should be good enough for you to get the full marks for that question. Question 4 says P is at the coordinate of minus 5, 1 is a point on the circle, x squared plus y squared equals 26. Work out the equation of the tangent at P. Now what we need to do here is, first of all, let me just do an example of what that tangent is. And remember that tangent hits a line at one point only. So what I need to do first is I need to work out what the gradient of that line is going to be. Now, as I mentioned, that the radius, so the gradient of the radius, and it's got grad, equals, and again my 2 points are 0, 0, and at this point here is minus 5, 1. So if I call this my x1, y1, and this my x2, y2, to work out the radius of those points, it's going to be 1 minus 0 over minus 5 minus 0, which gives me a gradient of minus 1/5. Now this therefore means that the gradient of the tangent is going to be the negative reciprocal of this. So it's minus 1 over minus 1 over 5, which is going to give me a gradient of 5. So what I've got is I've got m equals 5. So from this, what I've then got is if I've got m equals 5 and I've got my coordinate of minus 5, 1, I'm going to use this to substitute into my equation of a line. Obviously, a tangent is a straight line. I'm going to use this formula. So then what we then get is y minus 1 equals 5, then it's x minus minus 5, which then becomes x minus 1 equals 5x, and that's going to be plus 5, so it's going to be plus 25, and so y equals 5x plus 26, and that therefore is the equation of tangent. So looking at question 5, it says the circle x squared plus y squared equals 13 has a line of 5y plus x equals 13. And it says the question is asking me to work out the length of the chord AB. Now in terms of the word intersect, it means basically I need to find the coordinates of A and B. So find the coordinates of AB. Now one thing I do know is that these two lines from O to A is going to be the radius of a circle, so that's going to be root 13, and this length here is going to be 13. So is there a way I can find out what those intersection points are going to be? I'm going to say no. So I'm going to have to use simultaneous equations to then work this out. So what I've got is if I make y the subject, so I've got 5y plus x equals 13. And I'm going to rearrange that so I've got x equals 13 minus 5y. Then substituting that into the equation of the circle, I'm going to end up with 13 minus 5y squared plus y squared equals 13. If I expand this out, then what I'm going to end up with is 169 minus, and then it's going to be 65y minus 65y plus 25y squared plus y squared equals 13. Now neatening all that up, what I end up with is 26y squared minus 130y, and then it's going to be 169 take away 13, which gives me a plus, and it's going to be 156 equals 0. Now from this, what I then want to do is now go on and solve this. Now obviously I can divide everything by 2, so I've got 13y squared minus, let's just double check to make sure 13 is, so yeah, I could divide both numbers by 13, in which then I get 2y squared minus 10y plus 12 equals 0, and again I can simplify that further, so I've got y squared minus 5y plus 6 equals 0, which I can then factorize to give me y, and it's going to be 3 and 2, and it's going to be a minus and a minus, so y equals 3 and 4y equals 2. Now then substitute it back into this formula here. So again what I've got is, let me just split this up. So when y equals 3, I'm going to end up with 15 plus x equals 13, so x equals minus 2. So from this I've got the coordinate of A equals minus 2, 3. And when y equals 2, I'm going to end up with 10 plus x equals 13, so x equals 3. So the coordinate for B is going to be 3, 2. So from this then, all I then need to do is use the formula for the distance between 2 points. So it's going to be, if I just label these x1, y1, x2, y2, I'm going to end up with the square root, just put that there, of x2, y2, so it's 3 minus minus 2 squared, plus and it's going to be 3, no, it's going to be 2 minus 3 squared. So what I end up getting is 5 squared plus 1 squared, which is going to give me square root of 26, and that should give me the answer to what I'm looking for, which it does. So the length between A and B is root 26. Now the next part then says show that the angle is equal to 90 degrees, and let me just go back to the question. So what I'll do is this shows that this angle here is 90 degrees. Now there's a couple of ways in which we could do this, but basically the best way is to compare the gradient. So what I do is work out the gradient of AB and multiply that by the gradient of the OB. And let's change that to AO.com. So from this, what we've then got is, so the gradient of AO is going to be, I'll just write down what the coordinates are. So I've got A is minus 2, 3, B as 3, 2, and O as 0, 0. The gradient of AO is going to be 3 minus 2, minus 0, minus 0, which is minus 3 over 2. And the gradient of BO is going to be 2, 3, and I've got minus 0, minus 0, which is 2/3. So here equals minus 3 over 2 times 2 over 3, which equals minus 1. So therefore, the angle AOB equals 90 degrees because they are perpendicular. Then moving on to question 6, it shows that the line y equals minus 3x plus 10 is a tangent to the circle. So if it's a tangent, so if the line is a tangent, then there should be only one intersection point. So when I use the simultaneous equations of both this and this, I should only end up with one set of coordinates, because obviously a tangent only meets a particular circle or a curve at one point. So here we've got y equals minus 3x plus 10, and I've got the equation of a circle, which x squared plus y squared equals 10. So I've already got y the subject, so what I'm going to do is I'm going to swap y with minus 3x plus 10. So what I end up with is x squared plus minus 3x plus 10 squared, and that equals 10. So then what I've got is I've got x squared plus, and it's going to be minus 3x plus 10 minus 3x plus 10 equals 10. And so I've got x squared plus, and I end up with 9x squared, and then it's going to be minus 30x minus 30x plus 100 equals 10. And then neatening all this up, I get 10x squared minus 60x plus 100 equals 10. You can see how it slowly starts to take the form of a quadratic. So I've got 10x squared minus 60x plus 90 equals 0. Divide everything by 10. So I end up with x squared minus 6x plus 9 equals 0. And I can then factorize this. So I've got x minus 3 squared equals 0. So x equals 3. And then if x equals 3, using the equation of y minus 3x plus 10, y equals minus 3 times 3 plus 10, which is going to be minus 9 plus 10, which is 1. So the coordinate then, so here the intersection point is equal to 3, 1. And so as there is only one intersection point, the line is a tangent. And there we go.